Good morning. Today we are working on our last objective of the year, which means we need to be ready for that test next week. Remember, tomorrow is field trip, Monday no school for Memorial Day, practice test Tuesday. So I was trying to get us to work on those help sheets yesterday. You're going to have to just add this one last objective to that help sheet. Be ready for the test. Practice test Tuesday, real test Wednesday. So for our last objective, we have CO70. I can determine whether polygons are congruent, similar, or neither. Who remembers what that word congruent means? Laurel. The same. So congruent polygons are polygons that are the same shape and size. All sides and angles are congruent. They are identical. An example would be if we have this polygon A, B, C, and D, and then we have this polygon that is W, X, Y, Z. I could say that AB corresponds with WX, BC corresponds with XY, CD corresponds with YZ, and DA corresponds with ZW. They match up, they are the exact same. So when I'm looking at those sides, they are all congruent, all the same. Now, a similar polygon are polygons that are the same shape, but different size. That means the angles are congruent, and the sides are proportional. Every side. So same shape, different size. So an example of that would be if we have this triangle that is, let's say, A, B, C, and then we have this triangle that is X, Y, Z. If this is 8, 14, and let's say 4, this would be 4, this is not to scale, 4, 7, and 2. So they're proportionate. So I divided each side by 2 and I get these measurements, right? Proportional. Divide every side by the same number and you get the same thing. So AB goes with XY, BC. So AB connects with XY, corresponds with that. BC goes with YZ, and CA goes with ZX. So if I take AB, that 8, and I divide it, I put it over XY is 4, right? I can take BC, put it over YZ, and take CA and put it over ZX. When I divide them down, I get the same number. This is key to how to determine if polygons are proportionate. If they're similar, you have to match up the sides and divide every set of sides. They have to be corresponding sides, right? AB corresponds with XY. Sometimes your polygon might be flipped or turned. You have to look to see what does it match up with. And when you divide down, you get the same number, same decimal. We're going to practice with that. And if it's neither, it means, well, they're not identical, same shape, same size, and at least one of their sides is not proportionate. Okay, so if it's not congruent and it's not similar, it's going to be neither. So, this is important. Do not just look at it and say, well, it looks to be proportionate. It looks to be the same. You have to prove it. So if we look at our first two triangles, what do I have to do to prove that it's either congruent, similar, or neither? Henry?
You have to turn into a fraction.
Yeah. We have to match up every single set of sides. So I'm going to call this triangle A, this triangle B. I'm going to match up A sides to B sides. So let's start with the 12. What does 12 match up with? Joe? 4. So what does 15 match up with? Kevin?
5.
And what does 9 match up with? Colton? 3. Now I need to divide. Numerator divided by denominator. What is 12 divided by 4, everyone?
3.
What's 15 divided by 5?
3.
What's 9 divided by 3?
3.
So, are my triangles congruent, similar, or neither? What do you think, Elliot? So, if it's congruent, it means it's the same shape, same size. Are they identical numbers? So can it be congruent? Congruent's the one that you can rule out right away. Or you can say, oh my goodness, they're all identical numbers. If they are identical sides, then you know it's congruent. We have different numbers, so we know it's not congruent. So is it similar or neither? Colin? Similar, because they all divided down to the same number. So this would be similar. I do not want to see you write similar without proving it. You have to prove that they are similar. We will have some polygons that some sides are proportional and one side is not. So you might look at the first two sides and go, oh yeah, it's proportionate. Uh-oh. You have to match up every set of corresponding sides and divide it down. Let's look at our next one. What do we match up? Look at those two shapes. Can we tell if it is congruent? Yes or no?
Yes.
But on the top I have a 6 and I have a 22. They're not the same. Clara? But if this is my A and this is my B, my top is 6 and my top is 22. How is that congruent? You have to flip the shape. Sometimes, remember I said you have to flip or turn to match up your sides. So if this is my short side on A, I want to match that with my short side on B. So you always have to think, is it a corresponding side? You can tell short side to short side, long side to long side. So those 6 and 22s match up, and then my diagonals are both 19. So I know I don't have to prove it with the math because my numbers are identical. If the numbers are identical, you can write congruent without having to prove it, because it's proven by same numbers. If those numbers are not identical, you must match up every set of sides and divide down, because there will be some that are tricky. On the homework, on the test, you have to match up every side. You can't just look at it and say, oh, these sides are proportionate, so I'm just gonna write similar without showing and proving with the math and catching the one side that doesn't fit. So let's look at our homework page. Keep in mind that you might have to turn or flip. It doesn't look like we have to turn or flip on our homework, but you might have to on the test. So on the top, you're gonna draw and label each pair of figures. So you could do triangles, you could do squares, rectangles, you could do any polygon that you want, but you have to show, keep it simple, right? I like my triangles, I like my rectangles. If they're congruent, prove it with your labels. They are similar, prove it with your labels. Make sure all the sides are proportionate. And if they are neither, prove it with different labels. Make sure they're not proportionate. That next section says determine whether polygons are congruent, similar, or neither. Explain how you know. That explaining how you know can be that work that you're showing. Those fractions divided down. Do I get the same answer every time I divide? If they are not the same answer every time we divide, it is a neither. Don't trust your eyes. Don't say, well, it looks proportionate. Prove it. Figures may not be drawn to scale. Okay. Prove that they are similar or neither. Then on the bottom we have our review. So make sure you know it, because that's going to be on the test. Any questions? Okay. Work calmly and quietly on this. Add this objective to your help sheet. And then it is quiet work time, math packets. If you have retakes, I can help you with those practice works. All right, calm and quiet.